Hi, Savannah. We'll get started in just a few. Give it one or 2 minutes more, and then if nobody else shows up, we'll get started. All right, I'm gonna go ahead and share my screen. Just as a reminder, this session is being recorded, and I will make the recording available as soon as I get it captioned. You can find the recording for this class meeting, as well as our prior class meetings. In the announcements, it says videos from class meetings. If you click, there's actually a link to recordings for each of our sessions, unless no students show up, and then I don't make a recording. So let's take a look at the weekly overviews real quick. You can see from this weekly overviews that next week is the midterm week. Just for your information, and I will post an announcement as a reminder. The midterm will open on the 1st and it's due on the 8th. And because next week is midterm week for you, we won't actually have a class meeting. Okay. But I will post announcements. But I want to go over the material in the midterm week overview so that you have all of the instructions that you need, especially since we aren't going to meet next Tuesday. Okay. So again, you can go right to the weekly overviews, click weekly overviews, and it says midterm week overview. If you click there, you'll come, you'll see all of these instructions and information listed. Okay. So again, your completed midterm exam is due by Saturday, the 8th of October at 11:59 p.m. Just like you submit assignments on Saturday, regular assignments on Saturday, you'll submit the midterm on Saturday. You'll be using HonorLock to take the exam. And I posted for you the Honor Canvas guide that if you follow step by step, you can set up your computer to take the exam. Of course, as I mentioned in the syllabus from day one, there is a proctoring fee associated with Honor, and that is $27 for the entire semester. That's because with a $27 fee, you're paying for the midterm and the final. So choose the $27 option, it'll save you a couple of bucks. And then I suggest that you use the, you try to practice exam first to work through all of the kinks of making sure everything is set up correctly. And then once you have, once you're comfortable that everything is functioning properly, then click on Honor Lock on the left menu. Honor Lock, and then you'll see a link to the midterm exam. So I'm going to temporarily switch the student view so that you see, what it'll look like to you. Okay. So on the left menu, there's an item that says Honor Lock. If you click, okay, the exam for the midterm is not there yet because it doesn't actually become available until the 1st. But again, try to practice exam to make sure that everything is functioning properly before you attempt the actual exam. I see a hand up. Let me leave student view and just unmute yourself and ask your question if you have one, please. Okay, I'm going to stop the share temporarily because I'm not sure if the person on the iPhone has their hand up and they can't unmute. If you can't unmute, please, yes, Damian Joseph, yes, I see you here.
I'm here.
I see your hand up. So you have a raised hand on the screen, so I didn't know if that meant you had a question.
No, I just want to let you know I'm here.
Oh, no problem. I see when you come in automatically.
Okay.
Yeah. Okay.
All right.
So I'll go back to sharing my screen. So again, from the weekly overviews, if you go into the exam overview, the midterm exam overview, it tells you, the process, the information that you need to successfully take the midterm exam. If you click on the logistics handout, logistics link, I'm sorry, it tells you that, gives you all of the particulars of the midterm exam. So you'll have 4 hours to take the exam because you're taking it within, within Honor Lock, and the fee is explained to you. Please don't email me any of your work. Make sure that all of your work for the exam is typed in the exam space. You must show your work to get credit. So you type all of your work in the exam space. Do not email me your answers. If you don't show work, you will not get credit. Okay. And please, if there are any instructions that are particular to a certain question, make sure you follow them. The midterm exam is worth 100 points. And, each question will have the point value indicated. And then about a week after you finish the exam, I'll score it and you'll have your scores available. And I only give makeups if you have documentation to support your absence or missing the exam. And that is, something official like a doctor's excuse or something to that effect. But again, you take the exam online through Honor Lock. Once you are in the weekly overviews and you've tried the practice exam and you've set everything up, got your camera going, everything's, working properly, then on the left menu, you simply click on the Honor Lock link, and then you will be able to access, of course, you see all of what I have set up here, but you would be able to access the midterm exam starting on the 1st, okay? Right now, the practice exam is the only thing that you have available. So in fact, I'll make sure that you can, there it is, a practice quiz, right? Okay, so it's available, it's open, and then on the first, the midterm will open, all right? So if you have any questions about the midterm exam, I'll be happy to answer them for you. Just unmute, ask your questions, or if you have a question and you can't unmute, just type it in the chat. I'm looking to see.
Are you able to hear me?
Yeah, I can hear you just fine.
Okay, the practice exam, is that kind of like a study guide, or is it just to get us used to honor lock?
It's just for you to work out the kinks to make sure honor lock is working okay. In the
Okay.
midterm week overview, you can see that there's a midterm
Oh.
exam study guide, right? If you click on that study guide, so let me break that down for you. So the study guide is for you to practice as well as obtain bonus points. So if you, the way the study guide works is these listed here are all the topics that we've covered that are going to be on the midterm. So the scientific method, experiment process, 1D motion, units and unit conversions, projectile motion, uniform circular motion, and vectors. Nothing that we cover tonight is on the midterm. Okay, Newton's laws, which is the topic for tonight, is not on the midterm. Up through last week's material. Okay, last week's material, the last topic we covered was 2D motion, and it dealt with projectiles and uniform circular motion. That topic area is the last thing that we covered that will be on the midterm. So these are the topic areas. Now, what do you have to do for the study guide? So for the study guide, it says, use any source of your choice. Use any source of your choice to find conceptual information and sample problems that relate to the topics listed above. I'll give you some hints. In the announcements, the extra resources that I provide are fair game. Also under useful links, there are lots of sources. There are textbooks, there are free websites. You can use any of those or any other website that you like and find concepts and problems that relate to these topics. You have to list 10 concept facts and solve 10 problems. Now, you don't have to solve 10 problems on each of the topics, 10 problems overall, 10 concept facts overall. But my suggestion to you is to spread it out. You should at least try to find one concept fact and one problem on each of the topics, and then you can, concentrate on whatever topic area that you might be struggling with the most, or whichever one you have access to, you're wanting to find more information on. But to get the bonus points toward the midterm, you must at least have 10 different concept facts and 10 different problems relating to these topic areas listed. So a total of 20 items, 10 concept facts, 10 problems, okay? If there are examples in my lecture notes, meaning in the weekly overviews, you can't use those. But the extra notes and anything you find in the extra notes or useful links or any on the videos, any of that stuff is fair game, okay? Now, you submit that by email to me on the 8th by 11:59 p.m. and it's worth 10 bonus points toward the midterm score, okay? Any questions on the study guide? So in essence, what you're doing is you're creating your own study guide, which means you can focus on those things that you feel are more important for you to study. Some things you might know well, right? And you can breeze through that stuff, but then there's some things you might want to focus on more. So I'll leave that up to you to decide. Of course, it goes without saying, if you're working toward the midterm, and you have questions, please don't hesitate to reach out. What I will say to you though is, once you start the midterm exam, it's pretty darn late to get your questions answered, okay? Unless you find some type of administrative or logistical error, typing error in the exam itself, You want to make sure you get all your questions answered before you start the exam. Okay. So work out all the kinks with your setup by taking the practice exam and make sure honor lock is functioning okay. You've got a study guide to make sure that you're ready to deal with the material. And then, once you start the exam. Now, the other thing too is, and it tells you in the instructions here, in the logistics, you can use any printed material that you want. You can have formula sheets. You can print out the solutions to the problem sets, the discussions. You can bring textbooks. You can bring notes. You cannot use a computer, a phone, or a tablet, like to go to other websites, right? So you can't use your phone, a tablet, or any other websites, but you can use any printed material that you want, okay? So if it's something that you want to use to help you with the exam, print it out, bring it with you, okay? And when I say bring it with you, I mean to wherever you're going to be when you take the exam, because you're doing it online. Any questions? So I'll stop the share just for a moment to make sure I answer any questions that you have.
No, ma'am.
Okay. Savannah, are you good? Any questions?
I'm good. Yes, ma'am. I'm good.
Okay. All right. So let me go back and go into the share screen mode. And that'll do it for the exam. And the reason I'm covering it now is because we don't meet next week. And the exam is going to actually open Saturday. So the midterm exam will open Saturday the 1st and it's due the following Saturday on the 8th. We don't meet next week. So I wanted to make sure that the instructions that you needed to follow are good. Okay. All right. So let me jump into this material on Newton's laws. So up to now, we've been really focusing on kinematics. And that, that means pure motion, right? No focusing on the causes for the motion, or no focusing on forces. Well, this week, we start looking at forces. And in order to do an adequate and decent coverage of forces, we need to understand Newton's laws, because Newton's laws explain how forces affect motion. Okay. And so you can see from the objectives some of the types of things that we're going to be looking at in order to understand Newton's laws and all the terminology that's relevant for forces. So we'll be looking at some different types of forces, things like weight and normal force. We'll talk about the idea of balanced and unbalanced forces. We'll look at action-reaction pairs. We'll learn how to take forces and create a diagram to help us better understand how those forces are acting on an object, and then use that to help us apply Newton's laws. Okay, so the objectives here are the kinds of things that we'll be focusing on that you should be able to understand and do as a result of interacting with this material. Activities on your plate. You do have a problem set number 5. Problem set number 5 deals with 2D motion that we covered last week. Because remember, problem sets always lag a week behind. And then you'll have a discussion on Newton's laws that you'll have to complete by Saturday. And then your first bonus, in addition to the study guide. The study guide is a bonus that goes toward the midterm, but this bonus that's listed here that I'll talk about also can go toward your midterm score, okay? So that means as of right now, you have the opportunity to earn 20 bonus points toward your midterm score, okay? If you do both of them. But, bonuses are not mandated. That's totally up to you. The study guide is not mandated. That's totally up to you. But if you do them both, and email them both to me, you have the potential to get 20 bonus points on the midterm exam. And I'll cover that here in just a few. All right, so you have available here the notes that are relevant for Newton's laws. Chapter 5 in the textbook, which is provided here, deals with Newton's laws. There's some videos. I've bookmarked a NASA website that does a great job of talking about Newton's second law. And then I'm going to go into the supplemental notes and talk about Newton's laws. Okay, so before I jump right into that, let me go ahead and talk about your first bonus, because actually the first bonus deals with circular motion. Okay, so if you go out to this NASA website on the International Space Station, and if you were here last week, I talked about the International Space Station. It is a satellite that is currently orbiting the Earth. It's a low Earth orbit satellite, a LEO. And I want you to go out to this website that NASA provides and utilize it to, find information regarding the International Space Station. So what kind of information do I want you to find? So go out to that website and write a brief description of something that you learned about the International Space Station from the website, whatever it is. There's lots of good information out here. You can go and click around, browse, and if you find something interesting, then you can share that with me. And then there's a locator tool. Okay, so here it says find the International Space Station, right? And so you have to enter your town or your city or town, and then use it to see when the International Space Station is going to be passing near your hometown. Well, sometimes your city or town might be too small and is not readily referenced on NASA's website. So you might have to put the closest town or city to you. So for example, you might not find Sorrento, but you might find Gonzales, or you might not find Reserve, but you might find Laplace. Okay, so that kind of thing. You put the closest, biggest, closest city to you if you're a small town, and see when is the International Space Station going to be passing in your area, and you share that information as well. So those two things: something that you learned about the International Space Station, and when is it going to pass over your hometown or closest city. You write up those two things in a document, email me the document, and then that's worth 10 bonus points toward the midterm. Okay. All right. So that takes care of that. So now what we have to do is get into Newton's laws. Okay. Apologies, it's taking a moment to come up as usual. There we go. Okay. So again, these objectives come right out of the weekly overview. So dynamics. So again, when we talk about kinematics, we're talking about describing the motion of the object, looking at things like displacement, velocity, acceleration, time, speed, distance. But nothing in kinematics helps to explain what's responsible for the motion. In order to talk about the things that are responsible for the motion, we move to a dynamics description. So in dynamics, we start to look at the factors that cause and control motion. okay? So we're moving from kinematics to dynamics. And in fact, I will say we're not moving from kinematics, we're just adding to our description a dynamics perspective or dynamics description of motion, right? So when we're gonna describe an object, a moving object using a dynamics description, we focus on things like force, mass, inertia, okay? And so we're adding another layer of complexity, right? So we're not abandoning velocity, acceleration, so on and so forth. We're just adding force, mass, inertia to the kinds of things that we can use to describe a moving object. Remember, the whole idea behind all of these properties is that these are properties that can be measured and quantified, right? So something else that we can measure regarding our moving object, okay? And so they mentioned here that there are a lot of different people who are key to helping us establish dynamics, laying the foundation for our understanding from a dynamics perspective. They mentioned Galileo, very critical because he did a lot of experiments, that helped us to get a better picture of moving objects, not the most complete or correct, because he had real misunderstanding where friction was concerned in some regards, but way better than what the Greek foundation regarding motion that had been developed. So from the time of the Greeks until Galileo, you can see a profound increase in correctness in our ability to describe moving objects. And then ultimately, Isaac Newton comes along and really helps us to have a more correct and mathematical way of describing moving objects. In fact, even though we don't use it in this class, Newton and some other folk developed calculus as a mathematical tool to describe moving objects. So the reason Isaac Newton helped to invent calculus was totally so that they could look at this idea of dynamics. Okay. And so, there's so much that we do at this level of physics that is direct result of Isaac Newton's genius and his capability of mathematically describing moving objects in the most correct way at that particular time. Of course, that later on folk like Einstein and many others came along and gave other key information that helps us to understand motion and our physical environment. But a good deal of what we're able to do is directly the result of the work that Isaac Newton did. In fact, if you watched yesterday, NASA firing that spacecraft into the asteroid and deflecting its path, a lot of that work is possible because of our understanding of gravity, which is at its core the work of Isaac Newton. All right, but motion and this type of motion physics or Newtonian mechanics wasn't the only thing that he contributed. There are so many things that he was interested in, light, and as I said, calculus, gravity, but we give him credit definitely for the laws of motion, which are, as they mentioned here, the basis of dynamics. So if we're going to use Newton's laws, we have to have some fundamental understanding of what force means. What is force? Okay. And so, you have some intuition about force. That's not a foreign term to you because, you've you know, you pushed or pulled on things at some point in your life, or if you didn't, you've seen somebody push or pull on something. And so that's how we'll define force in a very intuitive and simple way. Force is a push or pull. Okay. And then you also have some intuition about the idea that if we push harder, things move faster. So, you know, you have intuition and experience with forces, even if you have not looked at them in a mathematical kind of way. Okay. And so that's where we start with this whole intuition. And in fact, that's where Isaac Newton started, you know, with this intuition about this idea of pushes or pulls. And he used that to help develop this mathematical way of looking at force. Okay. And so in dynamics, we're explaining the motion of objects as a result of the forces acting on them. Okay. And because forces or pushes or pulls, inherently there's a direction involved. Every force has an amount and a direction, a magnitude and a direction. And that is where our understanding of vectors come in, because we use vectors to explain properties that we measure that involve magnitude and direction. Sometimes in print form, you'll see bold letters used to indicate vectors. We don't have to get into all of those kinds of details. We just have to understand that a force is a vector because it has a size, which is its magnitude, and a direction. So when we represent forces as vectors, we have to, you know, understand that they can be added or subtracted. Forces can be added or subtracted just like any other vectors. We didn't actually have an in-depth lecture on vectors, but because that was the particular week that nobody showed up. But you should have gone through the material on vectors, and if you went through that material, you saw that basically if forces are pointing in the same direction, just like if vectors are pointing in the same direction, you can add them up. If forces are pointing in opposite direction, that is equivalent to subtracting them, right? So when more than one push is in the same direction on an object, they add together. If you know your forces are opposite, like in a tug of war, you could imagine you subtract them, and then whichever force is biggest is the one that wins, right? In a tug of war, if you have two teams pulling in opposite direction, and one team is pulling with more force, then the overall result, the overall force, is going to be acting in the direction of the larger force. And we call that a resultant force or net force. So a resultant force or net force is what you get when you add forces together or subtract them. Okay. And now we don't focus on internal forces because we're not looking at things at an atomic level. We focus on external forces. And these are forces that are acting outside of an object, but upon an object. Okay. So external forces. And that's an important distinction. Okay. So net force is the overall force or the resultant force that you get when you add or subtract forces. And these forces are external. They're acting on the object from outside. Excuse me. A free body diagram. So what a free body diagram does is it takes an object and it shows all of the different forces acting on it. So it kind of looks like the sketch that you see on the right side. So the beautiful thing about a free body diagram is that we can imagine taking an object. Let's imagine that the object in this picture is actually a car. Well, we've shrunk that car down to a dot. So we can represent our object by just drawing a dot. And then we can show the forces acting on the object by drawing vector arrows extending in whatever direction the force is acting. So in this particular picture, you see we have two forces acting on our object. Imagine that this is, like I said, imagine that that dot represents a car. And so we've got one force pulling on our object, pulling it to the right, looks like. And we've got one force, F2, pulling, up on our object. F1 pulling in the positive X direction and F2 pulling in the positive Y direction. You can think of it that way, okay? So a free body diagram is a way to simplify the scenario by collapsing the object into a dot and then just drawing vector arrows to represent the forces acting on the object, okay? And you know from your study of vectors that if you change the size of the arrow, excuse me, that's how you represent a different magnitude for the force, right? If the vector arrow for F1 were shorter, then that would mean the force would be, smaller. Okay. So now that we understand what force is and how we can represent force and how we can use vectors to help us represent force, now we can start to talk about Newton's laws of motion. So Newton's law of Newton's laws of motion are comprised of 3 laws that help us to explain and predict motion. Remember, a law is limited in its scope, and it relates to a singular phenomena. And in this particular case, motion is the phenomena that we're talking about. And those laws help us to explain and predict motion. Okay. And so, these laws were built over time using the observations and findings of folk like Galileo and Kepler. Kepler's laws are fundamental in terms of understanding the motion of planets. And in fact, Kepler has 3 laws as well. And we'll kind of look at those, but not right at this point. We want to keep it focused on Newton's laws at this point. But Newton was very humble in saying that, he wouldn't have been able to do the work that he did without the knowledge that had been, uncovered and made available by Galileo and Kepler. All right. So they also mentioned Newton's law of gravity. We'll be talking about that later. Not next week because we won't meet next week, but the following week is when we'll kind of take a deeper dive into gravity. We'll have a kind of a limited exposure to gravity today to help us understand weight, which is a force. But to get a more in-depth study of gravity and how Newton's work plays into that, we'll be doing that 2 weeks from now. So Newton's first law of motion. Newton's first law of motion says that a body at rest will remain at rest, or if it's in motion, it remains in motion at a constant velocity unless acted upon by a net external force. And I know I read that kind of fast, but I did that on purpose because it is a mouthful. But what I'm going to attempt to do for you is to break it down in a way that helps you to make sense of all of the parts. First of all, I don't necessarily like the word body. I get, back in his day, probably in England or wherever he was doing his work at, that might have been a cool word, but I like the word object better, okay? And so I'm gonna read this in a little bit different way. So the first thing that Newton's first law says is, an object at rest remains at rest unless acted upon by a net external force. So if the object is at rest, meaning what? Stationary, it is going to remain stationary unless you act on it with a net external force. So unless there's some net force on an object that is stationary, it is not going to move. Okay. If it's not moving, it will not move unless it's disturbed by a net external force. Another way to say that net external force is unbalanced. So an object that is not moving will not move unless it's acted on by an unbalanced force. But that's not all that Newton's first law says. It says, or if an object is in motion, it will remain in motion at a constant velocity unless acted upon by net external force. So let me read that a little bit differently. If an object is moving, it will continue moving at the same velocity unless acted upon by an unbalanced force. So basically what Newton's first law is saying is that whatever the object is doing, it wants to keep doing that. How do you change what it's doing? An unbalanced force or a net external force. Okay. So what Newton's first law is saying is that there must be a cause in order to change the velocity. Okay. In order to change an object's velocity, there must be a cause in the form of this net external force. I like to think of it this way. If I want to accelerate an object, I must have an unbalanced force acting on that object. Okay. And that's what it means when we say change the object's speed, direction, or both, right? If we change speed, or we change direction, or we change both, we're changing the velocity. What does it mean to change an object's velocity? Accelerate. So Newton's first law is clearly establishing for us what it takes to change an object's motion. And that change is what we call acceleration. And that thing that must be present, that cause, is an unbalanced or net external force. Okay. So, to understand Newton's first law completely, you have to be able to pick it apart just the way that I just did and be able to say what he's saying in multiple ways using different terminology. And you'll have a chance to do that on the discussion or problem set relating to Newton's laws. Okay. And so it says here, intuitively, we see that items at rest tend to remain at rest unless we push or pull them. True. You look around your house or wherever you're at right now and look at all the things that are stationary, meaning they're at rest. And just think about it. They will not move unless you apply a force to them. Okay. But we can't lose sight of the fact that Newton's first law also says that if an object is moving, it is going to keep moving unless you push or pull it. Okay. All right. Now, where did folk like Aristotle go wrong? They didn't account for friction. So, they thought that an object's natural tendency was to come to a stop. Everything in their mind, everything wants to come to a stop because all they could see was things stopping, right? But they didn't understand that the thing causing those objects to stop was friction, which is a force. Okay. So Newton comes along and he turns that around and says, no, the natural tendency is not to come to a stop. The natural tendency is to keep doing whatever it's doing. And the reason things that you're talking about come to a stop is because there is an unbalanced force on them, friction. Okay. So you see where Aristotle and even Galileo to some extent got things wrong. Newton came along and gave the correct explanation. Okay. Now, in order to have a real appreciation for this idea of net force and acceleration, we have to talk about something that we hadn't so far. We've talked about acceleration, but we didn't talk about acceleration from the perspective of it being a change in an object's motion because of force, because of unbalanced force. Okay. But now, if we're going to include forces in the picture, we have to understand this principle of inertia, and also something that we've talked about, but only from a unit's perspective, we have to understand mass. Okay. So sometimes you hear Newton's first law called the law of inertia. And that is the tendency of an object to remain at rest or in motion with a constant velocity. Inertia is an object's tendency to keep doing whatever it's doing. Or sometimes I like to say inertia is the ability of an object to keep doing whatever it's doing. Because some objects have more inertia than others. Some objects can keep doing what they're doing because they have a lot of inertia. And they give the example of a large boulder. Well, that object has a lot of inertia. And so it's going to be much more difficult to change the motion of an object as compared to, for example, a tennis ball. And so how do we know how much inertia an object has? By measuring its mass. Mass is a property that tells us the quantity of matter within an object. How much stuff is it made of, right? More stuff, more inertia. More stuff, more mass. And so we know, because we've looked at the base properties and base units and the metric system, we know that the standard unit for mass is the kilogram, right? But at its core, mass is the amount of matter within an object. And more mass, more inertia. More inertia means the object can, put up a fight to changing its motion, if you will, right? It's gonna be harder if it has more inertia to change whatever that object is doing, to change its state of motion, whether that means it's at rest or moving with a constant velocity. Okay. So it says here at the bottom of the page, it says objects with greater mass not only possess greater inertia, but they also apply a greater gravitational force upon other objects. We'll explore that in 2 weeks when we talk about gravitation. But for now, you need to understand that an object that has more inertia has more mass and has more weight. Okay. Newton's second law. So Newton's second law of motion says, it is a mathematical way of looking at the cause and effect relationship between force and changes in motion, between force and acceleration. Okay. So Newton's first law says, hey, if you don't have an unbalanced force, no changes in motion. Newton's second law says, hey, I have an unbalanced force. How much of a change will I get? Okay. So Newton's second law is a way of quantifying the amount of acceleration based on the amount of net force. Okay. So what we look at here is the relationship between a net external force. Remember, we're not dealing with internal forces here. So that's why they don't write net external. Just the idea is that it's the net force that produces a change in motion. It's the net force that produces an acceleration. And so we can express Newton's law simply as F net equals ma. Okay. So you can see from that relationship how force, mass, and acceleration are related to each other. More net force, more acceleration. More mass, less acceleration, right? So they're showing you in the picture here, the person is exerting the same amount of force on a basketball or a car. You can see that because of the mass of the basketball, they'll produce a large acceleration compared to the amount of acceleration that they produce on a car. Okay. So same amount of force, but because the mass of the objects is different, the acceleration is different. Okay. Gravitational force and weight. So we've talked about gravity from the perspective of acceleration. We know that gravity produces an acceleration 9.8 meters per second squared down on an object that is in free fall, right? No air resistance. But what we haven't talked about is gravity from the perspective of a force. And for now, we're just going to focus on gravity from the perspective of weight. Weight is an example of a force. It's a type of force. But 2 weeks from now, we'll look at gravity in a bit more detail. Okay. So when we apply Newton's second law to an object, we can see the relationship that they give here. W equals minus mg. Remember, they're writing that from a vector perspective. That's why it's bolded. And that negative sign tells us that gravity points down. So if we want to know the amount, the size, the amount of weight or the amount of pull that an object experiences due to gravity, we take the object's mass and we multiply by g. Okay. And we always have to keep in our minds that that's pointing downward. That's why it's negative. All right. So now this is important. It says the equation shows that mass is an intrinsic property, meaning an object's mass is the same no matter where you go. An object's mass is location independent. An object's mass is the same on Earth as it is on the moon or Mars, whereas an object's weight varies according to gravitational field. In other words, as the gravity changes from place to place, an object's weight changes from place to place. Okay. So your weight is different on the moon than it is on Mars, but your mass is the same no matter where you go. Okay. So I always have to keep that straight, because we kind of sometimes talk about weight and mass being the same thing. And that's okay, because there's a weight mass equivalence because gravity is pretty much the same on planet Earth, right? But you have to, from a physics perspective, you really want to distinguish the two. And that is that to get an object's weight, you take the object's mass and multiply times gravity. How do you get the object's mass? That's an intrinsic property. You can measure it using a mass scale, and that tells you how much inertia the object has, okay? So now that you have a new property, force, you need a new unit. And the unit of force in the metric system is the Newton. You can see on the bottom there. So you got a new unit to add to your list of units, right? How do you get a Newton? You multiply 1 kilogram times 1 meter per second squared. 1 Newton is 1 kilogram times 1 meter per second squared. Newton's third law. So Newton's third law looks at the symmetry of forces, meaning that these forces exist in pairs. And so we'll talk about the idea of action-reaction pairs when we talk about Newton's third law. And so that third law says, whenever one object exerts a force on a second object, each object experiences a force that is equal in magnitude but opposite in direction. So let me break that down. Okay. For every action, there's an equal but opposite reaction. For every action force, there's an equal but opposite reaction force, meaning they're equal in size, but they point in opposite directions. So Newton's third law tells us that forces occur in pairs, okay? And you can see from the picture what they mean. So for example, the swimmer pushes on the wall. Newton's third law says the wall pushes back on the swimmer. How much? Same amount, opposite direction. Okay. And so the swimmer is going to push on the wall with a certain amount of force, but the amount of acceleration is based on the mass of the object. Well, we hope that when the swimmer pushes on the wall doesn't collapse, right? That's pretty much a given. So it means that the wall is not going to accelerate, or the acceleration will be very, very small. But when the wall pushes back on the swimmer, because the swimmer's mass is not as much, the swimmer is going to experience an acceleration. Okay. Now, you have to be very careful with these action-reaction pairs. They don't cancel each other out. You may be looking at the picture going, but they're equal and opposite. Yeah, they are, but they're acting on different objects. The swimmer is pushing on the wall is pushing on the swimmer. They aren't acting on the same object, so they can't cancel out. Types of forces. So in using Newton's laws, you'll come across different types of forces. You know, we kind of categorize forces based on how they're transmitted and what kinds of effects they produce. Okay. So we typically, you know, push and pulls, all of them kind of fall into the category of a push or pull. It's just that we sometimes give names that are a bit more descriptive than just push or pull. Okay, so things like thrust, lift, drag, those are all kinds of forces. For example, when we might be talking about an airplane in motion, you know, thrust and lift, for example, drag as in air drag, right? Weight, friction, normal force and tension. These are all names that you come across that, you know, kind of discuss the type of force that's involved. So you saw weight, for example, already. Friction is a force between surfaces that we kind of talked about, and the goal of friction is to oppose the motion of the object. Okay, so friction is one of those big forces that we deal with, because a lot of times when you're analyzing the motion of an object, it's always present. Okay. A lot of times, you know, for simplicity, we say no friction or no air resistance, but truthfully, friction is in most circumstances, whether it's friction because of air, friction because of water, friction because of some type of surface to surface contact, is pretty much there. And so its goal is to oppose the motion of an object. All right. Now, spring forces and restoring forces, we won't talk about those now. Another force that you come across is normal force. Normal force is also a contact force, and you can think of it this way: normal force is what balances weight in many instances. When things are touching, the normal force is typically a way of balancing weight. Okay, and then tension. Tension is usually mentioned when we talk about ropes or cables or chains, those kinds of things. The tension in a rope, the tension in a piece of string, that kind of thing. Okay. So here's a picture or a visual regarding normal force. So you see we have the dog food that's sitting on the table, the bag of dog food. Okay. And that bag of dog food is being pulled on by gravity, because that's what weight means, right? Weight is the pull of gravity on an object. Okay. And so we have weight pulling down. Well, if the table does not exert a normal force upward on the bag of dog food, then it will simply fall through the table, right? It's kind of like walking on a floor that has old floorboards, and you fall through. Why? Because the floorboard is not able to exert a normal force equal to your weight. So you fall through. Now you have to be careful here because you see, we might be tempted to think that these are equal and opposite according to Newton's third law. But we have to be careful because the weight of the object is gravity pulling on the bow wow child. The normal force is the table pushing up on the bow wow child. If those things are balanced, then the object is not going to accelerate. Okay. All right. So you have to be careful when you apply Newton's laws to a particular object to pick out the forces acting on that object. Okay. So normal force is typically the force that balances weight, as it is in this picture. Tension. Tension is a force that's exerted in a cable or rope or string, and we use the symbol T. Just like in the picture above, you notice we use the letter N to represent normal. That N does not stand for north. Some students, for some reason, think that's the case, but that is not the case in a free body diagram. We use N to represent normal force. We use W to represent weight, and we use T to represent tension. They mentioned that you use the symbol, the letter F for friction. Okay, so it's important to know the terminology and the symbol, the appropriate symbols to use, so that when you draw a free body diagram like the one on the right, you adequately represent the forces that are being exerted on an object. So in this particular case, they took that whole block that has a mass of M and they condensed it down to that dot. And then they show that there's tension from the rope pulling up on the block, and there's weight from gravity pulling down on the block. And if those things are balanced, then the block is not going to accelerate. But if one of the forces, the tension or the weight, is bigger, then the object is going to accelerate in that direction because there will be an unbalanced force. And then finally, they talk about in this slide the 4 fundamental forces of nature. There are 4 forces. We do not deal with the electromagnetic, weak nuclear, strong nuclear force in this class. We focus strictly on the gravity force. And you might be thinking, yeah, gravity, you know, it's the force between big planets, big stars, you know, but it's actually the weakest force. Gravity is actually the weakest force. And you can see that just by looking at the fact that the exponent on gravity is like to the minus 38. So it's very small compared to the electric force and the nuclear forces. Okay, but you know, you don't necessarily have to know any of that. It's just, you know, just information sharing. So you can kind of have some perspective of the fundamental forces found in nature. All right. So that's pretty much what I wanted to cover with you regarding gravity. Regarding forces. In the announcements, if you recall, we have our extra notes folder. It says extra resources. If you click on that link, remember there's a folder for every topic that we cover. Let me blow this up a little bit. So you can see here, there's a folder dealing with Newton's laws. And let me do it this way. The one on fluids, we don't really focus on that, but excuse me. There are some good examples worked in this packet. So you know, I'll just kind of quickly go through it because it really is kind of a restatement of much of the stuff we've already looked at. This packet here that says Newton's laws, it is just that it's 3 or 4 slides that have Newton's laws. That's it. Nothing more, nothing less. So we've already seen that. You can look at the fluid stuff, but it's not anything that I cover in this class, not anything you're going to be tested on. On this package that says force def is basically the definition of force and a look at Newton's first law. Okay. Pretty much all the stuff that we've talked about already. The one thing I will focus on here is this one here, because this is a common misconception of students. So in the picture, it shows that there's a normal force up and a gravity force down. And they're balanced because they're both 20 newtons. And so the question is, you know, the statement is this object must be at rest, right? And it says because there's no net force acting on it. And that is absolutely false. Net force doesn't cause motion. Net force causes a change in motion or acceleration. So you don't have a net force here, so you can't accelerate. It doesn't mean you can't move. This thing could be moving at a constant velocity and still not accelerating and still have balanced forces. Okay, so just keep that in mind, that what we're looking at here is the idea of acceleration, which is a change in the object's motion. If you don't have this net force to produce an acceleration, then you won't change the object motion, meaning it will either stay at rest or keep moving with the same velocity. Okay, and then in this particular packet, there's kind of a reiteration of some of the different types of forces. I do like that they have a Newton's second law broken down in this format. They have it broken down in this format and they explain the unit for you. And then there are some sample problems that utilize Newton's laws at the end of the packet. Okay, so you know, this extra notes resources, this is very handy, something that you can utilize and go through to get some additional perspective and practice with Newton's laws. So I would encourage you, if you've not been using these extra resources that I've made available in the announcements, extra resources, that you go and take a look, because there are a whole host of PowerPoint presentations and example problems worked in this material. You can definitely use it for your study guide. You can definitely use them as part of what you might want to print out and have available when you do the midterm exam. All right. So with that, I'm going to stop my share and ask if there are any questions.
I don't have any questions.
Damien, do you have any questions for me? All right. Well, I'm not sure if he might be having trouble. He's using the iPhone. So if you don't have any questions for me, Savannah or Damien, that is basically it for tonight. I'm gonna stop the recording and